What's up, everybody? I'd like to welcome you all to my demo today. We're going to be going over how to build, deploy, scale, and secure containerized workloads across a hybrid cloud environment. What the hybrid cloud is kind of means different things to different people depending on who you ask. But from Red Hat's perspective, hybrid cloud means an approach to providing your users and developers a consistent cloud-like experience regardless of where your workloads exist. We're going to be working primarily with OpenShift today, but we're also going to be working with some XKS clusters as well. We're well aware of the fact that OpenShift may not be your first, nor your only choice when it comes to your container adoption strategy. But our goal at Red Hat is to give you the tools you need to be successful, regardless of where those workloads sit. So let's take a minute to talk about the tools we're going to be using today. For our platform, we're going to be using a mix of OpenShift clusters, both on-prem and in the cloud. And we're also going to be working with XKS clusters from the three major hyperscalers, AWS, Azure, and GCP. We're going to be building and deploying an app on OpenShift pipelines and OpenShift GitOps. We'll be using advanced cluster management to demonstrate management of workloads across non-homogeneous K8s clusters. And we'll be using advanced cluster security for real-time scanning of container workloads. And with that, let's get into it.
Today, we're going to be working with the OpenShift Pipelines operator, which can be installed from the Operator Hub on any OpenShift cluster. Navigate to the Operator Hub, search for Pipelines, and install it. Once installed, you'll have a new option on the navigation bar to the left named Pipelines. Now, let's take a look at the pipeline I created for our demo today, the Hello World pipeline. This is a pretty straightforward pipeline consisting of just 5 steps. Generate build ID, which creates a timestamp-based unique tag for our new container image. Git clone, which pulls down the source code from my Git repo. Maven, which will compile the source code into a jar file for us. Builda, which will then build and push a container image to my container registry. And finally, Git CLI will update the manifest and push those changes back up to the Git repo for deployment. Let's click on Action and select Start. Here we can see some parameters I've created for the pipeline. These are variables that can be accessed within the pipeline. New tag pulls the build ID from the first step in the pipeline for use when Builda creates the new container image, and the manifest is updated to reflect the new image tag. Old tag is pulled from the existing manifest. Token is a Git token. There are 3 ways to set up Git authentication within a Tekton pipeline. Basic, which uses username and password, using SSH keys, or using a Git token. Now let's take a look at workspaces. Workspaces are a virtual sandbox where persistent data can be stored for use during a pipeline run. Since Tekton runs your pipeline in containers, by definition, they are ephemeral. If you need to persist data across more than one step in your pipeline, such as compiled software, you need to provide a workspace with some persistent storage. You can also provide a workspace with resources like config maps or secrets. In this case, we just need to provide our pipeline with some storage to clone our Git repository to. You should be mindful of the size of your source code and application. For this application, we're just building a simple Spring Boot app which only uses a few megabytes of storage. So the default PB size of 1 gigabyte is more than adequate. By selecting Volume Claim Template, our pipeline will provision a PVC for our workspace using whichever storage class we choose, or you can just accept the default storage class for your cluster. Now let's kick off the pipeline by clicking Start. If we navigate to logs, we can watch what the pipeline is doing in real time. Generate build ID creates a timestamp for us. We can see Git clone pulling down the source code from our Git repo. Maven is going to compile the source code into a jar file. This is a simple Spring Boot Hello World application, so it doesn't take long. As we can see, Maven successfully built our jar file in about 10 seconds. Obviously, for more complex applications, this is going to be a more CPU-intensive process and will take longer. Builda is going to build a new container image for us using the Docker file in our Git repo. It's a simple JRE container image that exposes an HTTP service on a TCP port. Then it's going to tag the new container image with the build ID generated in the first step and push it up to our container registry. And finally, the Git CLI step is going to update the manifest file with the new image tag and push the changes back up to the Git repo. And there you have it. Our pipeline ran successfully. And we can see our new container image was just pushed to the registry a few seconds ago, and the deployment YAML was updated with a new tag.
Next, we're going to be working with Argo CD to deploy our application. Like all the software we're going to be working with today, OpenShift GitOps, aka Argo CD, is available as an operator. Navigate to the Operator Hub and search for GitOps. As we can see, there are both community version of the Argo CD operator and the official Red Hat OpenShift GitOps operator available. Once you've installed and configured the operator, you can click on the grid icon up at the top and you'll get a link to your Argo CD instance. This is the Argo web user interface. Before you can deploy an application with Argo, you're going to need to configure a few things. You'll need to register a cluster. Then you're going to need to create a project. A project is where you'll define the scope and permissions that Argo has on your cluster to create resources. You can get pretty granular with defining Argo's permissions with allow and deny entries for clusters and namespaces. For the purpose of this demo, I've just used wildcards. Now we can create an application. Click on New App. Give your app a name like Hello World. We're going to select the Hello World project I previously created. For the sync policy, you can select either manual or automatic. For the purpose of this demo, I've set it to manual so you can see in real time what happens when a sync is kicked off. But if you were to set it to automatic, basically as soon as new changes hit the Git repo, your app would be automatically synced and redeployed with the latest version, hence continuous delivery. Select Auto Create Namespace, and we'll select Replace, which just means that any resources that are created by this project will be overwritten when a sync kicks off, which is fine for this demo. For the repository, we're going to select our Git repo where the manifests are stored, which is in the Hello World Git repo under the YAML directory. Then we specify our local cluster as the destination URL. We'll be deploying to the Hello World namespace. Then we can create an app by clicking the Create button up at the top. Since I selected manual as the sync policy, the resources were not automatically created, so Argo CD is flagging the application resources as out of sync and missing. Let's kick off a sync, and the resources will be deployed for us by Argo CD. Now we can see that Argo CD has created the resources. Let's hop back into our OpenShift cluster and we should see that the Hello World namespace has been created and that our app has been deployed. And there it is. Next, we'll be working with Advanced Cluster Management to deploy our application at scale. Once ACM is installed and configured on your OpenShift cluster, if you look up at the top left in the navigation bar, you'll see a new tab labeled All Clusters, which is how you access the ACM dashboard. Under the Clusters tab, we can see all of the clusters I'm managing with ACM. I have 7 clusters here. 4 OpenShift clusters, including my local OCP cluster, a ROSA cluster on AWS, an Arrow cluster on Azure, and a dedicated cluster on GCP, as well as 3 XKS clusters, including an AKS cluster, an EKS cluster, and a GKE cluster. ACM is first and foremost a cluster lifecycle management tool for OpenShift, but it also acts as a governance and compliance tool for Kubernetes workloads. Note that I said Kubernetes and not OpenShift. Let's go ahead and take a look at the application dashboard. One of the really cool features of ACM is that if you have Argo CD deployed to your OpenShift cluster, any application deployed to your cluster is automatically populated into the ACM dashboard. There are 2 ways you can deploy an application across multiple clusters with ACM, either with an Argo application set or as an application subscription. For the purpose of this demo, we'll be creating an application subscription. Creating an application subscription on ACM largely does the same thing as Argo. It watches a Git repo for changes to the manifest files and synchronizes those changes, so in a way, ACM could be utilized as a sort of CD tool. However, that's not its primary function. ACM uses application subscriptions to enforce compliance with a single source of truth, in this case, a Git repo, and if it detects any deviation, it will automatically remediate your application, keeping your workload secure and preventing configuration drift. Click on Create Application and select Subscription from the dropdown. Under Name, we'll enter Hello World Multi-Cluster, and we're deploying our application to the Hello World namespace. Under Repository Type, we'll select Git. Just like with Argo CD, we're going to be using the hello world.git repo under the YAML path. We'll select Replace for the reconcile option. Then we'll scroll down to our cluster selection. If you wanted, you can use cluster labels to specify where you want to deploy your application. For instance, you can create tags for your dev, test, and prod clusters and select which environments to deploy to that way. For the purpose of this demo, we're going to be deploying our app to all of our clusters. Click Create. Eventually, the app would synchronize itself, but we'll go ahead and click Sync manually. Now let's take a look at the Topology tab. This is largely going to be the same thing you'll see in Argo CD, just flipped 90 degrees. As we can see, some of the resources failed to deploy. In some cases, this is because the application already exists on the local cluster. In some other cases, it's because the target cluster can't create the resource type, as is the case with routes. OpenShift understands what a route is, but our XKS clusters have no notion of this. However, all of our clusters are capable of creating a load balancer service, which is how we'll be accessing our application. Let's get the external IP of our load balancer services on all of our clusters and verify that our app is accessible from each cluster. We can use the same command on every cluster to get the IP. kubectl get svc-n hello world. Now let's start opening up browser tabs. And there you have it, the same application deployed at scale using ACM across a non-homogeneous hybrid cloud environment. Next, we'll be working with Advanced Cluster Security. ACS is an operator based on StackRox, which is a security tool for real-time scanning and reporting for container workloads. Like ACM, it also supports both OpenShift as well as most modern Kubernetes clusters. As we can see here on the Clusters tab, all of my 7 clusters are registered and reporting to StackRox Central Instance. Let's take a look at the dashboard. We can see here that some critical vulnerabilities have been identified by ACS. It looks like the Spring Boot application we deployed earlier has the Log4j vulnerability and needs remediation. When deploying applications at scale like this, patching vulnerabilities could quickly become extremely cumbersome. But thanks to the fact that we previously set up a proper CI/CD pipeline, remediating even the most severe security threats is quick and easy. To remediate the Log4j vulnerability in our Spring Boot application, all we need to do is update the code libraries in our source code to the latest versions. To make things quick and easy, I've written a patch file to do this for us. First, let's pull down the latest commit from our Git repo. Then we'll patch the pom.xml file. And then we'll push back up a new Git commit. And now we're ready to rerun our CI/CD pipeline. Now let's make sure that the new build has been synced. And there you have it, the Log4j vulnerability has been remediated from the app on all 7 of our clusters in just a few seconds. So let's recap. Today we've covered the following. We used Tecton pipelines to automate building of an application. We used Argo CD to automate deploying our application. We used Advanced Cluster Management to manage our container workloads across non-homogeneous container platforms. And we used Advanced Cluster Security for real-time scanning and reporting on our container workloads at scale. And then finally, bringing it all together, we reused all these technologies to quickly and efficiently remediate a critical vulnerability from our workload across a hybrid cloud environment. Thanks for watching.